Okay, this video is going to introduce the idea of a complex number or an imaginary number. It's actually not the same thing. Complex and imaginary numbers to students that have never used these phrases before. Now, I'm going to preface this by saying that part of growing up is finding out that your math teachers consistently lie to you throughout your lives. They tell you, oh, 4 minus 6, you can't do that. You don't have 4 to take, or you don't have 6 to take away from 4. That's not true. You just are not prepared, math-wise, to know about negative numbers yet. They tell you, oh, you can't divide that pie, those 3 pies between 8 people because that can't be done. 3 is not divisible by 8 evenly. But then later on we learn about fractions, and that's really not very true. Same sort of thing goes on all the way growing up. And we end up at this situation where we tell students in Algebra 1 and pre-algebra, oh, you can't take the square root of a negative number. That's not true. Now this should look familiar from earlier in the school year. Earlier in the school year, when we talked about rational and irrational numbers, we said, here's a box. That box contains every number you've ever dealt with. They're broken into 2 number sets. The rational numbers, symbol for that is a Q, and the irrational numbers. They're not important enough to get their own symbol. Usually you see a capital I. Now within the integer, or within the rational numbers, darn it, there are a number of other number sets. The largest of those sets is known as the integers. That is a Z with an extra crossbar as the symbol for the integers. Those are your positive and negative whole numbers. So blah, 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 -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, etc., etc., etc. Within that set is a smaller, infinitely large set. And my things are like getting worse and worse, so I'm going to have to adjust them on the fly here. There we go. Known as the whole numbers. Again, not independently interesting enough to get a special symbol, so they're just usually seen with the letter W. That is 0 plus all of the positive integers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. up to, well, goes on forever in theory. And then within that is an even smaller number set that's actually almost exactly the same size, called the natural or counting numbers, which is an N with an extra leg. Those are your 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. This should look familiar from earlier in the year when we discussed number sets. But what we didn't tell you earlier in the year is that you take the irrational numbers and the rational numbers, you put them together, that's the real numbers. But the real numbers are only part of all numbers. There is actually a larger set than the real numbers out there. So we're going to put another box around this. This box contains every number that we use. These are known as the complex numbers. And please note that every number you have ever worked with has been a real number, but every real number is a complex number. Now the other thing is there are numbers you have not worked with yet. They are called the imaginary numbers. And they're based on the number I, which we will return to that in a couple of screens to talk in more detail about what I is. These are essentially roots, specifically even roots, So where your index is an even number, 2, 4, 6, 8 roots, 10th roots, 12th roots, of negative numbers. Now that's kind of a simplistic way to explain imaginary numbers, but we're at a high school level here. We're talking A2. So generally we're talking about the square root of negative numbers, which we've told you all along can't be done. That's not true. They absolutely can be done. We just hadn't talked about I yet. So we have these two new sets, the imaginary numbers and the complex numbers. They're not the same thing. Just like your rationals and your irrationals combine to make the real numbers, your real numbers and your imaginary numbers combine to make the complex numbers. So let's talk a little bit about complex numbers. Every complex number consists of a real part and an imaginary part. They can be written in the form a plus bi, where a and b are real numbers, but b is being multiplied by I, which is the imaginary number. So this part, bi, is your imaginary part, and a is your real part. When you combine the two, you get a complex number. Now, all along we have dealt with numbers where the imaginary part of that number is equal to 0. In that case, you have a real number. So that would be all of the numbers that you're used to dealing with. All of them. Every single number you have ever dealt with in your life is a real number. It's a number, it's actually also a complex number, but it's a complex number where the imaginary portion of the number is equal to 0. Now, if the real portion of the number is equal to 0, that is the situation where you have an imaginary number. They really only come in a couple of different forms. You generally see them as an integer or a root attached to the letter I. Something like that. Could be positive, could be negative, that doesn't matter. What matters is that they contain an I. Or as the square root or fourth root or sixth root of a negative number. Okay, even roots can have imaginary roots. So we need to be watching for that as we go on deeper into Algebra 2. So that brings up the question, okay, we've got these imaginary numbers. What the heck is I? Well, your real number system, the number system you've used all the way up through grade school to this point, is entirely based on one number. The number that every other number is based on is the number 1. Well, this imaginary number set is built on not only 1, but also the imaginary unit, I. Mathematicians invented I and defined it as equaling the square root of -1. Now, the first skill, there's a couple of skills for I, very basic skills that we need to know going forward, but this video is just an introduction. So for now, we're just going to stop and say this at the very end of the video. I is the imaginary number. It is equivalent to, it is defined as the square root of -1.